A piecewise function is a function that has different rules for the range of x or values of x. So also, a piecewise function do not overlap. Here's what I'm trying to say. If you have f of x equal to, let's say, 3, 0 less than s less than 4, then 5, 4 less than s less than 6, something like this. Take note that you cannot be having equal to on both sides. In real sense, please. I know that when it comes to Fourier, I don't know, some expressions are being written weirdly. But two values cannot be overlapping. So you cannot be having s equal to 4 here, and this is also equal to 4 again. So you can't be having that. So, but let's just leave that part. Let's just leave that part. Let's start what we are here for. Remember, this is why you are here. This is what you've been waiting for. This is what you've been waiting for. So let's start with the first one. The first one, and let me just call it A. So A says f of x is equal 4, 0. 0 is less than s less than 5, and 5 is less than s less than 8. So let's plot this one. So first of all, we know that it's going to be starting from 0 down to 8, so we only need positive parts of x. So this is x. Let me put my 0 here, that's 0. Let me put 5, so this is 5. Then let me put 8, so this is 8. So the first thing I'm going to do is, this is f of x, or which you call y. So it is equal to 4. So let me put 4 here. It's equal to 4 all the way from 0 to 5. So when it was 0 to 5, the value remained the same all the way from 0 to 5. So it's the same. Then you bring it down. 0 to 4 was the same. Take note that this vertical line does not matter. So it was the same. Then it was 0 from 5 to 8. So all you have to do is to kind of tick in this part, because this is 0 line. This is the 0 line. And that's just it. You've been able to graph that function. That's just what you have to do. You've been able to graph it. This is not looking fine. You've been able to graph the function. That's just it. So this is the answer to that very first question. Let's move on to the next one. There's no time. The next one is where problem starts coming in. B. F of x equal pi plus x from minus pi to x to 0, and pi minus x from 0 to x to pi. Okay, so let us plot this very one. Now remember that I said for me to have linear, when a line is linear, this is just x. For me to have linear graphs, I deal with the intercept. So the first one is pi plus x. So if I have f of x, which is y, so if y is equal pi plus x, what will be my x-intercept? Or you can see, this is 0 to minus pi, right? This is 0 to minus pi. So I can first of all say, okay, what is my y-intercept? When I put x at 0, y-intercept will be what? Pi. Y-intercept is pi. So y is equal to pi. Y is equal to pi. That's it, right? Good. So if y is equal to pi, when x is 0, let me say this again so you understand clearly. If you notice our interval here, this is s0. So when s is 0, if we should put 0 here, pi plus 0 is still pi. So y is equal to pi. That's why I said y is equal to pi when s is 0. Then the next value of s was minus pi. So if we should put minus pi here, so s is equal to minus pi. If we should put minus pi here, pi minus pi, because s is now minus pi minus pi is what? 0. So y is equal to 0. You see that, right? So you've been able to get that guy. Let me draw this so we kind of spot what's going on. So this is minus pi, this is my 0, and this is my pi. Okay, and this is my f of x, or you could just say that's y. So right now, the first thing we have is the pi plus x. Now when s was 0, y was pi. So when s was 0, y was pi. So let me put my pi here. So let it be this point. Let it be this point. So when s was 0, y was pi. Then when s was minus pi, this is minus pi. When x, this is my x-axis, when s was minus pi, y was 0. So it's going to be here. Take note that these two things are like intercepts. When x is 0, you have found the y-intercept. When y is 0, you have found the x-intercept. So that was what we did here. So right now, I can then connect this with a straight line. That's not looking fine, but yeah, you kind of get the picture. That's what I have. Now the next part is y equal to pi minus x. If you notice, the 0 part is still the same. So when s is 0, the value will still be the same because that's what we have. So let us put 0 here. So this is 0. Pi minus 0 is still 0. So y is equal to pi when s equal to 0. I don't want to be writing that. It's going to make the video longer. So s is 0. Pi minus 0 is pi. So y equal to pi. That's the first part. And this is pi, right? Good. If this is pi, when you put pi here, what will y become? Pi minus pi is 0. So y is equal to 0 when s is equal to pi. So again, this part has been plotted already. So y is equal to pi when s is 0. So s is 0, y is pi. That has been plotted already. Then the next one, s is pi. So this is pi. And then y is 0. So this part too. And that's just it. You've been able to plot that graph. So that's how to plot that one. That's actually very easy for you to plot. C, the next one. So we have f of x equal, that's a lot, x over 2 at 0 less than x less than pi, and pi minus x over 2 at pi less than x less than 2 pi. Okay, so let's do this. This one is still easy to plot. So the first thing is f of s is s over 2. So f of x is x over 2. So the first thing is when s is 0, because we have x at 0. So when s is 0, when s equals to 0, what will y become? This is s, right? And s is now 0. So this is 0 over 2, which is just going to be 0. So we have 0 at 0. So we have 0 at 0. Okay, so let's proceed. The next one, when s is pi, when s equal to pi, y will become, if you should put pi here, this will become pi over 2. So y is pi over 2. Okay, let me plot my graph somewhere here. So this is x, then this is y. Okay, so look at this. We're just having x over 2, right? So put 0 here. 0 over 2 is still 0, so y is 0. We're having pi, s is equal to pi. So put your pi here. This will be pi over 2, so which is what we have here. Okay, so let's plot this guy. So we have, this is from 0 to 2 pi. Oh, so we have only the positive parts. Let me adjust my y line. This is y, this is 0. Okay, so let me put pi here, and let me put 2 pi here. Okay. So let me put this guy here to be pi over 2. Let me put my pi over 2 to be, because we have y equal to pi over 2. So the first things first. When x is 0, y is 0. What does this tell you? This is the origin. When s is 0, y is 0, that's the origin, because this is 0, 0. So this is the origin. So there's a point right here. Then when x is pi, when s is pi, y is pi over 2. So when you sketch this, and so this will be here. That's where that point would be. So right now you can then connect this together. And that's what we've just done. We've connected that together. Okay, let's go to the next one. So when f of x is pi minus x over 2. So the first value we had was x at pi. So when s equal to pi, when s is equal to pi, This means my y will become, now take a look at this. I think I'm going to write this one because this is a lot. So we have pi minus x over 2, which is now pi over 2. So what is pi minus pi over 2? Pi minus pi over 2 is pi over 2. Let me put over 1 here. So the LCM of this is 2. 2 divided by 1 is 2. 2 times pi is 2 pi. Minus 2 divided by 2 is 1. 1 times pi is pi. So 2 pi minus pi, that's pi over 2. So that's what we have. So when s is equal to pi, y is equal to pi over 2. Okay, so that's what we have. Now the next one is 2 pi. So next, when s is equal to 2 pi, what would our y become? So we know that y is pi minus s over 2, right? So this is pi minus x is now 2 pi. So this is 2 pi over 2. So 2 we cancel 2. So we have pi minus pi remaining, which is what? 0. So when s is equal to 2 pi, our y is equal to 0. So sometimes I always say that sketching these graphs are always the easiest. Piecewise, they're always the easiest. So when let's do this guy. When s is pi, y is pi over 2, which is the same thing here. When s is pi, y is pi over 2. So it's the same thing. We've plotted it before. So right now, next one is when s is 2 pi, y is 0. So it's just going to be here. This is like saying our x-intercept because y is 0, s is 2 pi. So our intercept will be at 2 pi. So you connect these two together. And that's it. You've sketched that function. So these are looking like our top hat function. But let's continue. So this is what we have for the 2. D. The D part of this. Okay, so f of x is equal, this is looking like a lot, but let's continue. 3x over 4 from 0 less than s less than 4, and 7 minus x, 4 less than s less than 10, and minus 3, 10 less than s less than 13. Okay, so this is what we have. Okay, that's still not hard. That's still not hard. Okay, so let's get started, please. It's actually very easy. So the first one is 3x over 4. So let's start with when s is 0. So when s equal to 0, we know that y is 3s over 4. So if you should put s as 0 here, 3 times 0 is 0. 0 over 4 is still 0. So this will be 0. So you have s at 0, y at 0. So the next one is when s is 4. So when s equal to 4. We know that y is 3x all over 4. So if s is 4, this is 4, right? So 4 we cancel at 4. 4 we cancel at 4, meaning you have just 3 remaining. Easy. That's easy. Let me clean this part. Okay, so yup. Nah. Okay, so this is 0, 0. So this is f of x. Yep. Okay. So from 0, the equation is from 0 to 13. So we have 0 down to 13. And from that 0 down to 13, we have 0 to 4. So this is 0 down to 4, and then 4 down to 10, and then 10 to 13. So right now we have the first one. The first one that we have was 0 and 0. So that's the origin. This is the origin. Then when s was 4, y was 3. When s was 4, y was 3. So this is 3 here. So when you trace this guy and this point, so it's going to be here. Yeah. So this is what we have. So I have this guy like this. Okay, so that's for the first one. That's for the first part. Now the next one is 7 minus x. Sorry that I'm going to... So 7 minus x. So for 7 minus x, I'll say when s equal to 4, when s is equal to 4, we know that our y is 7 minus x. So if s is 4, what is 7 minus 4? 7 minus 4 is 3. So we've been able to get that point. The next one is when s is 10, y will become 7 minus 10 because it's 7 minus x, right? So 7 minus 10 will give us minus 3. So let's come back to our graph. So when s is 4, y was 3. We've been able to plot that. When s is 4, y was 3. Good. Next, when s is 10, so there's a point here, please. There's a point here. So when s is 10, y was minus 3. Minus 3. So let me put my minus 3 here. So if you kind of use a ruler, they're going to be intersecting here. So we're going to connect these two together. Yeah, because these are the two. This very one here is the 4 and 3. Then this very one here is the 10 and minus 3. So you've been able to connect them together. Next is minus 3. Next is when is what? When is minus 3. So minus 3 is just a horizontal line. This is your minus 3 here. So minus 3 is just a horizontal line. Just this horizontal line. And it's going to be ending at what? 13. It's going to be ending at 13. So that's just it. And that's it. You've been able to plot or sketch that guy. So this is just it. Sometimes, please take note that this line might not be, this vertical line is not that important. So it might not actually be drawn. Because in real sense, this is just what your graph should be. That's just what your graph should be, ideally. That's what your graph should be. Though it should be open here. I didn't really specify about the opening and the closing of points. You know, we're doing Fourier. But ideally, this point is supposed to be open because this is less than 13. If it was closed, I'm going to close it here. But since it was not, I'm just going to leave it like that. In this case, we don't want to pay attention to this. But in real sense, if you're plotting that guy, you should actually put that. Let's go to the next one, please. There's no time. Let's go to the next one. So for the next one, that's E. So for E, we have f of x at 7 minus 3x over pi. So this one is minus pi less than x less than pi. Okay. This is actually very easy. It's very, very, very easy. So for the first one, since every single thing here is just a straight, it's like a straight path. It's a straight path all the way from minus pi to pi. Let's put in minus pi first. So when s is minus pi, y will become, you know, you can do this by looking at it, but let me just put it in. So this is 7 minus 3 into minus pi over pi. So when pi should cancel out pi, minus 3 times minus will give me plus, right? So 7 plus 3 is 10. So I have that one. Look at it this way. If pi should cancel out pi, you have a 1 here. Minus 3 times minus 1, that's plus 3. So 7 plus 3 is 10. So the next one is when x is pi. That will become 7 minus 3 pi all over pi. So this will cancel out this. So 7 minus 3, that's 4. So now let's plot this. Let's plot this. Remember to hit the subscribe button and like this very video. Okay. So I'm going to be drawing my graph. And it's from minus pi to pi. And the y line is going to be at s equal to 0. So this is 0, 0. This is my y or my f of x line. So when s is pi, when x is pi, we have y at 10. Okay, so let me put my 10 here. That's a lot. Yeah, let me put my 10 here. So when x is at minus pi, we have it at 10. So the intersect these two guys together, when you trace this point to this point, it's going to be somewhere here. Then when s is pi, y is my just 4. Let me say my 4 is somewhere here. let me say my 4 is somewhere there. So together, it's going to be here. So I'm then going to connect a line to these two. And that's just it. Yeah, that's just what it's going to be. So that's for that very one. That's for that very one. Let's move on to the next one. So f. So for f of x is x at 0 less than x less than pi over 2. And then we have pi minus x at pi over 2 less than x less than pi. Yep, my main aim is to just sketch this. So first of all, this one is actually easy. You know how x looks like because we've done it before. We've done something like that. So right now, the first one is when s is this very 0 you see here. When s is 0, what will y become? We know that y is equal to x. So y will still be 0. Because this f of s equal to s means whatever you give to it is what it's going to give to you. So the input is equal to output. Because the input is directly equal to the output. So f of s, or you could say y is equal to x means whatever s is what y would be. So the next one, when s is equal pi over 2, this also means that y would also be pi over 2. So no stress. So, so that's what we have. That's what we have. Okay. The next one, for the second one, when x is equal pi over 2, because that's the first value here for the second one, when s is pi over 2, we have our y equal to pi minus x. But our s is now pi over 2. So this is pi minus pi over 2. Now, we've done this earlier on. I think that was question C. So pi minus pi over 2 will give us pi over 2 again. So this is what we have. Then the next and the last one is when x was just pi. When s was just pi, our y was pi minus x. So this will become pi minus pi. So that's 0. So that means the point we have is s equal to pi. We have the point s equal to pi, y equal to 0. Y here we have s equal pi over 2, y equal pi over 2. So let's sketch our graph. So this is y, this is 0. This right here is, we have all the way from 0 to pi. Then in between, we're going to have pi over 2. Okay, so right now, we're going to say that we have 0 and 0, that's the origin. So the origin is involved. Then we have pi over 2 to pi over 2. So y at pi over 2, let me put pi over 2 here. So when s is pi over 2, y is pi over 2. So together, they'll kind of meet at a point like this. Okay, then the next one, I'm going to connect this with a line first. So the next one says s is pi over 2, y is pi over 2, which is the same as this. So we've plotted this already. So the next one, when s is pi, y is 0. So when s is pi, y is 0, so which is this point here. Remember I said, if one part is 0, it means you have found the intersect of the other. So y is equal to 0, meaning we are finding the x-intercept. So x-intercept. So that's going to be there. So connect it like this, and that's what you have. So that's how to plot that very one. That's how to sketch that very one. Okay, the next one is G. So for G, f of t is equal minus 1 from minus 1 less than t less than 0 and 2t from 0 less than t less than 1. Okay. Now, sketching minus 1, that's not a problem. It's just a horizontal line. So let's leave that. Let's go to our 2t. 2t is still very easy actually. So let's go to 2t, please. So f of t is equal to 2t. Now, when t is 0, I know how this line is going to, this line is going to look like this one. It's going to look like this one, but it's going to move, yeah, it's going to look like this one. But it's going to move either like this or like this. So, when t is 0, when t is equal to 0, y is going to become 0 because this is 2t, right? So it says that whatever t is, you're going to double it to get your y, to get your f of t. You're going to double it. So if you double 0, it's still 0. Then when t is equal to 1, y will become 2 because if you double 1, you're going to get 2 because the function is just 2t. 2t means twice. That's going to become what you have. I can even plot this thing here. Yeah, I can even plot it here. So this is our t, and this is our f of t. So to start with, we have minus 1. So let me put minus 1 right here. Then my t value is from minus 1 to 1. So this is minus 1, this is 0, and this is 1. At the first point, they said from minus 1 to 0, we're having minus 1. So from minus 1 all the way to 0, the value was minus 1. So you have something like this here. Just that. So that's just a horizontal line. Now, if you wish, you can connect this together. If you wish. So that's what it's going to become. Then next, from 0 to 1, that's this point, we notice that the origin was included, 0, 0. So the origin was included. And then when t was 1, y was 2. So let me put 2 here. It's going to be like this. Okay. So that's just what it's going to be. And then, yeah. That's not looking straight. Oh no, this is even bent. Sorry for that. Okay. That's what we have. That's what we have. Okay. So that's for that. So let's go to the next one, GH. So for h, f of x is equal x plus pi over 2 from minus pi to x to 0 and x minus pi over 2 from 0 less than x less than pi. You know, sometimes when you see functions, you know that these functions are actually similar. Yeah. So functions are looking like repetition of what we've done before. But anyway, let's see how fast we can just do everything so we wrap up this episode. So for this one, I'm going to do much more fast. In a way, much more fast. So let's see. So for this one, we have this. So let's start with the first one, x plus pi over 2. So when s is minus pi, when s is equal to minus pi, hold on, let me see if a new marker would help. Let me see. So when x is minus pi, that means f of x, which is our y, would then become, if we should put minus pi here, s is minus pi, right? So minus pi plus pi is 0, and 0 over 2 is just 0. Let me say that again. The function is s plus pi, right? And we now have that s is now minus pi. So if you put s as minus pi here, minus pi plus pi is 0, and 0 over 2 is just 0. So that's the first point. Then the next point here is 0, right? So when s is equal to 0, which means we're going to be having 0 plus pi. 0 plus pi is pi, so that's pi over 2. So f of s is equal to pi over 2. So keep this, that's our first point. The next one, when x is 0, because for this second one we have x at 0. So when s is equal to 0, what's going on? Okay, let's see. So when s is 0, if you should put 0 here, 0 minus pi is minus pi. So this is minus pi over 2. So we have f of x equal to minus pi over 2. Okay, then when s is pi, when s equal to pi, f of s will then become, we should put pi here, pi minus pi is 0. So 0 over 2 is 0. So, like I said, this is actually very simple. So let's plot our graph. So it's from minus pi to pi. So minus pi down to pi. Then 0 is at the middle. Okay, then this is f of x. So the first one says when it's at minus pi, f of s is 0. So this is just this part. Because for you to say f of s is 0, remember that f of s is y, so do not be confused. So f of s is 0. So that means we have this 0 guy here. And this is x at minus pi. So the point is going to be here. X-intercept. Then when s is 0, y was pi over 2. So this is pi over 2. This point here. So these two will be joined together. Yeah, that two will be joined together. Then the next one is when s is 0, f of s was minus pi over 2. Now this is 0, right? They said y is minus pi over 2. So let me put my minus pi over 2 here. So that means this is an intercept. Because now, s is 0. If s is 0, it means you are finding the y-intercept. Remember I said that when we started this video. When s is 0, it means you're talking about the y-intercept. So that's what we have. Okay, then when s is pi, f of s is 0. So you have it right here. So yep, this is what it is. So that's your graph. So this is what the graph is going to be for that function. That was easy. So that's it. The next one, that's h. This is I. Yeah. So this one says that f of x is equal 1 minus x at I think I want to change this. Yeah, I don't want to look like, hold on. Okay, let's just see. Minus pi less than t less than, okay, no, this is x. Then 1 plus x at 0 less than x less than pi. There's a particular function that I'm looking for, and I have still not seen it. But anyway, let's hope for the best. There's something I wish to explain here. Let's see as we go, as we proceed. As we proceed, let's see. Okay, so to start with, when s is minus pi, this is weird. So when x equal to minus pi, y will become, we know that this is 1 minus x, right? So that is 1 minus, x is now minus pi. So this means we'll have y equal to 1 plus pi. That's weird. But let's proceed. So y is equal to 1 plus pi. Then next, when s is 0, y is just going to be 1. Because when you see 1 minus 0, that's just 1. So I'm going to keep that point. I'm going to keep that point. Okay, then the next one is when x is, because I'm doing this next one now, doing the next one. So when s is 0, again, when you say 1 plus 0, that's still 1. So y is equal to 1. Okay, and then when s is equal to pi, when s is equal to this very pi, because I'm dealing with this second one. When s is equal to pi, I have y equal to 1 plus pi. Okay, Now, 1 plus pi is about 4 point something. So let's plot this guy. Let's plot it. Okay, so it's from minus pi to pi. There's a 0 here. So let's see. Let's see what this will be. This is somehow. Okay, so when s is minus pi, this is minus pi, we have y at 1 plus pi. Okay, let me put 1 here. Let me put 1 here. And let me put 1 plus pi above it. Because 1 plus pi is bigger. It's bigger than 1. So when s is minus pi, y is 1 plus pi. So this is minus pi, and this is 1 plus pi. So it's going to be somewhere here. Yeah, it's going to be somewhere here. Okay. So when you take this point here and this point, it's going to be somewhere there. Then when s is 0, y is 1 plus pi. So this is 0, and this is 1 plus pi. So that's just this point here. When x is 0, y is 1. So this is telling us that, oh, our y-intercept is at 1. Our y-intercept is at 1 because s is 0. So y is 1. So you're only going to the point where y equal to 1, and that's where you're going to be dotting. So these two will be connected together. Yep. Will be connected together. So that's what you have. But the next one is when s is pi, because this points 0 and 1 is still the same with this. So I'm leaving it. I'm going to this very one. When s is pi, y is 1 plus pi. So this is pi. I think it's too far safe. The same 1 plus pi. So it's going to be somewhere here. And it will be joined together with this. Yes. And this is what you have. That's how the function will look like. Yup. It's fine, isn't it? That's how the function would be. So this is what you have. Let me give you some time to look at it and see if you understand it. Remember to hit the subscribe button, like this video, and share it across to your classmates. Let us proceed. Let's proceed. Okay, this is beautiful. It is. So J says we have f of x equal 2 sine x from 0 less than x less than pi, and then 0 at pi less than x less than 2 pi. Okay, let's get started. So first of all, when x, the first thing you need to know is this is like a curve. It's curved. It's not going to be straight, so be very careful. It's not going to be straight. So when x is equal to 0, I still want to do the same principle here so you understand. Y would then become, we have 2 sine x, right? So this will be 2 sine 0. And sine 0 is 0. So when you times that by 2, that's still 0. The next one, when s is pi, y will then become 2 sine pi. 2 sine pi. And we know that pi is equal to what? 180. Pi is equal to what? 180. Are you sure this one will do this thing very well? This is also, pi is 180, so sine pi is 0. Times 2, that's still 0. Okay. Okay. This one is not difficult to draw. But from this point, I want to do something. Let me draw this. Let's see. So this is 0, this is pi, and this is 2 pi. And then this is x, and this is f of x. Okay, so when s is 0, y was 0. So that is this point we see here. Good. Then when x is pi, y was 0. So which is this point here too. When s is pi, y was still 0. Okay. Now, you know that this is supposed to be like a curve, right? It's supposed to be a curve. So now take note. Take note. How do we then plot this? Remember that I said when you're plotting sine, that the number in front tells us how high the height of the diagram. So the height here is going to be 2. And since we're dealing with the positive part, since we're dealing with this part, this very part here, we're going to say that there's going to be a 2 here. There's going to be a 2 at this very point. Because 2 is going to be the maximum. It's going to be the highest height of this very function. It's going to be the highest height of this very function. Okay, so what I'm going to be having is going to be something like this. Let me see. I've told you the importance of these 2. Giving you the importance of that guy. Then, okay, so it's going to look like this. Yeah. That's how it's going to be. It's going to be like that. Where this maximum height is pi over 2. Where this maximum height is at the middle, pi over 2. That's how it's going to be. That is how it is going to be. Sometimes I kind of try to remember what I've done before to see if I did the right. Yeah, I think I did the right thing. Okay, so please, if you notice any mistake, please let me know. So this is what we have, because I can make a mistake. But let's see. I think every single thing is all right. Okay, then when it's at 0, this is just going to be a straight line or a line that collapses at this very point. And that's just it. That's just how to draw that graph. That's just it. Yeah. Okay, the next one is k. So for k, we have f of x equal to 0, from 0 less than s less than pi over 2, and then it is cos x at pi over 2 less than s less than pi. Okay, now for this one, let's deal with our cosine. So when x is equal to pi over 2, what is the cosine of pi over 2? Cos pi over 2 is equal to 0. Cos 90, you check this in your calculator. Cos 90 is 0. Cos pi is 180. 180 over 2 is 90. Cos 90 is 0. So the next one, when s is pi, because we're only dealing with this one. When s is pi, y will become cos pi, which is equal to minus 1. Okay, so let's plot this. Let's plot this. So we have from 0, and then we have pi over 2, and then we have pi, and this is x, this is f of x. Okay, so from 0 to pi over 2 was a flat line at 0. There was a flat line here. Then, when we got to pi over 2 to pi, now we then take note of this. So the only point we have was pi over 2, so 0. When s is pi over 2, y is 0. So come here, this is s at pi over 2. So that means this point is inclusive. Then the next one is when s is pi, y is minus 1. So this is x, and this is, let me put minus 1 here. So that's this guy here. Take note, don't connect them by a straight line because cosine is not linear. Cosine is not linear. Now this very graph you see here is also like a parabola. It's also like a parabola. So what we're going to have is, how do we then connect this to this? Because you need to be correct when you are doing this. So let me kind of draw this guy. Let me draw separate cosine. Let me just draw separate cosine from minus pi to pi, because that's 2 pi. It's going to be looking like this. This is 0. Yep. So you see how it's looking? That's how it's going to be looking. Yeah, that's how it's looking. So it's looking like this. Okay, so this guy you see here was just supposed to be something like, this is your pi over 2. So it's going to be like a curve, something like, I hope I did very well. Nah, that's not fine. Let me do something. Okay, so I'll put my pi here. I think this one is my pi. Okay. Okay. I think, yeah, but this is not inclusive. Okay. Yeah, it's not looking fine in my eye, so that one is better. That one is better. That one is better. Okay, so let me proceed. Let me wipe this part. Okay, so we have f of x equal to t plus pi, t minus pi less than x less than 0, and 0 less than x less than pi. Okay, now do you know what? I want to leave this one for you. I want to leave this one for you to do. Now try this out yourself. You can let me know the answer when you send me an email. So you can send me an email. I'll then check what the answer would be. So I think I'll leave that one for you because it's looking similar like it's looking like H. Yeah, it's looking like H. It's supposed to. So follow what I did in H to do this one. It's similar to it. So let's not make this long. So it's kind of looking like this. Yeah, it's kind of looking like this. So it's looking like H. So I've even drawn it. So you can just do that one yourself. So that's L, then M. F of t is 1 minus t squared from minus 1 less than t less than 1. This is actually the easiest to draw. Do you know why it's the easiest? If you should solve this quadratic, your answer is minus 1 or 1. If you solve this quadratic, that's your answer. So let me show you how. This is 1 minus t squared. So this is y equal to 1 minus t squared. So this will then become 0 equal 1 minus t squared. Take the t squared to this side. So this is t squared equal 1. T is the square root of 1 with a plus or a minus. So t is plus 1 or minus 1. So that's why I said that's the answer. So this is actually very easy for us to draw. I'm going to have something like this. So this is minus 1, this is 1, this is 0, this is t, and this is f of t. Now take note, this is where it becomes much more critical. Will this graph look like U or, sorry, why do I like calling this one U? Will this look like an N or a U? Would it be open upwards or open downwards? Now, since this is a negative t squared, since this is minus t squared, it's minus t squared, it means that it's going to look like this one. This is going to be, because this is when a is less than 0, while this is when a is greater than 0. It's going to look like this. So your graph is actually like this. Yeah, that's really like that. Now, if you're bothered about the vertex would be at 0. Why would it be at 0? If we should add these two together, minus 1 plus 1 over 2. So this would be, hold on. Did I say 0? Hold on. Minus 1. Our solution is this. So this is 0. No. Our vertex would be at x at 0, or should I say t at 0, then 1. So it's going to be at, yeah, it's correct. It's 1. So t is 1, this is 0. So that's how it's going to be. So it's going to be at this point. So yeah, I was correct. Okay. The next one is n. The next one is question n. Don't worry, we're almost done with this. Almost done with this. Almost done. So let's see. This is n. So for n, we have f of x equal x bracket pi minus x. And this is from 0 less than x less than pi. So that's actually an easy one to draw. It is. It's actually an easy one to draw. It is an easy one to draw. Okay. Now, let me put, because I different, you know, the thing is, you just have to know what you should do at some point. So I feel like what I want to do is to put in my 0 and put in my pi. Or better still, I could say that, this is normally y. So this is 0 equal to x into pi minus x. So any of them could have been 0. So this s is equal to 0, or pi minus x is equal to 0. Don't know why. Okay. Yep, that's looking better. So this is s equal to 0, or this here actually means that pi is equal to x. If we should take the minus s to the side, pi is equal to s, or you could say s equal to what? Pi. So it means that your x-intercept would be at s equal to 0 and s equal to pi. Yep. So this is what it's going to be. Then what do you think would be your vertex here? Your vertex will become xv. The x value for the vertex will be 0 plus pi over 2. So this will then become pi over 2. So that's the x value for the vertex. Then the y value for the vertex is, take this pi over 2, put it back into this expression. Put it back into that expression. So that will be pi over 2 brackets pi minus pi over 2. Because anywhere you see s, you're going to put pi over 2. So this is x, pi over 2, pi minus this is s again, pi over 2. This pi over 2, pi minus pi over 2 is pi over 2. We've done this before. So this will just become pi squared over 4. Okay, so let's then plot it. Okay, I have just from 0 to pi. So this is 0, and this is to pi, and this is x, and this is f of x. Okay. Okay, let me put my pi over 2 here. Yep. So I know that upon expansion, if I should expand this, I'm going to be having pi x minus s squared. So my parabola will still look like this, because the s squared is negative, so it's still going to look like this. Then, so it's from 0 to pi, so it's going to be like a dome. It's going to be like a dome. So that's it. Then this point here, which is the maximum, the value of y here is pi squared all over 4. So yeah, that's it. Oh no, that's too high. So that's how to plot that very one. That's how to plot it. And the last question for the day. 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 Let me see. Okay. I think I might add one more though. But let's proceed. So this is O, because there's a question I just remembered. F of x is equal s squared over 4, 0 to x to 4, then we have 4 from 4 to x to 6, then we have 0 from 6 to x to 8. Okay, now here's one thing I want to say about our parabola s squared. So s squared, if you divide it by something, you are making it wide. Let me explain. If normally this is our s squared, and you divide it by something, you're going to make the s squared open up more. But this is when you divide by something. But if you should times s squared by something, you're going to make it much more tinier. So right now, your division by 4 is going to make this thing much more wider. But let's proceed. What I've just said might not be useful to plotting this, but the knowledge is very important. But you can still do this, you can still solve this without stressing yourself. So now we know that if s is 0, please take note, if s is 0, when s is 0, When s is 0, y would also be 0 because 0 squared is 0. So 0 over 4 is 0. Then when s is 4, so when s is 4, 4 squared, y would then become 4 squared all over 4. So which is 4, right? Because 4 squared is 16. 16 over 4 is 4. So that's what we have. So that one is much more easy. But please take note, because s is equal to y here, s is also equal to, does not mean that it's a linear expression. It is quadratic. It is quadratic, so it's going to be a parabola. So let me do this. Then, yeah, s is just 0, 0. If you solve this expression, s is at 0. So what I'm going to be having is going to look like this. Yeah, so we have from 0 down to 8, and then from 0 to 8, we have 0 to 4, and then 4 to 6, and then 6 to 8. So now let's get started. Let us get started. So this is y equal to 4. So let me put my 4 here. Now I have this and I have this. If you look at this graph, s squared is normally like this. But since we're considering from 0, so it means there will be, this point will not exist. We're just going to be having something like this. So this is this. So what we have is, yeah, going to look like this. Beautiful. Then the next one, what I've just drawn right now is s squared over 4. So that this is s squared over 4. Then the next one is just 4. So it's just going to be a straight line. Y is equal to 4. It's just going to be a straight line. Just a straight line down to 6. And then when it's at 0, that's just a line here. Ideally, all of these were not supposed to be connected. But let's just put that, since when it comes to expressions on Fourier, we kind of have that. Okay, so this is what our graph will look like. And yep, with this, that's the last one that I have here. So the problem I wanted to do before, I kind of think I've sketched it before. Yeah, let me see. F of x equal 3x minus s squared from 0 less than x. I think I should just say less than